All right, we can go ahead and get started. I know everyone's just excited to get started, so let's start now. Where we left off on Friday, we were playing around with a couple different workarounds for sort of sharing data between functions, how we can potentially return multiple things at the end of our functions using either pointers or arrays. And actually, we'll see structures are going to be another kind of, not workaround, but allows us to return multiple things via one function call here. And as part of that, we were starting to play around a little bit with how we want to actually structure our projects. And here I mean like our programming projects, our replit projects, it's all kind of referring to the same thing. And the truth is there isn't one correct mechanism. Here is the correct way to structure your project. There's just different opinions, different style guides is what you would read. This is one, the links here on the slides on Canvas. I like that approach. Another approach to take would be to review any of those open source libraries we've been using this semester. The standard C library is also, of course, a very good open source library, but it's attempting to do a lot of things for a lot of different people, so maybe it's a bit too complicated. But look at the libgd source code and see, here is how they structure that project. And then that's a good way to get a feel for how something can be organized with regards to your project. I think ultimately, you still have to kind of break down the problem you're trying to solve. You have to think about how you want to organize things, and then following any of these style guides would lead to a reasonably well-organized project. But following a style guide doesn't solve the problem of how do I think about my code and how am I going to write functions that are appropriate for it. But the high-level recommendations, at least from that style guide that I thought was pretty decent, is to separate source into code, separate source for data, and then header files. And then header files should be somewhat coherent in terms of the group of files that it is effectively serving. From that style guide is just this header file example, and your header file should look something like this. The first thing that we hadn't talked about but is mentioned in this iBook is this concept of a header guard. And the idea is that there's some downside of accidentally multiply defining things like functions or constants or types. Compiler doesn't actually like that. It wants for a given function name with a particular set of input and outputs that should be defined exactly once in your program. This hasn't been an issue for us yet, and it probably won't be an issue for us all semester unless we kind of copy paste things a little wonky this semester. But as your projects get more complicated and you have 5 header files and 15 C files and you're including things in different order depending on how you see they may be needed, you can run into this issue that if you define this in one file or one place here, and then later on in the same program you redefine that same function prototype, that will lead to a compiler error. So the most straightforward kind of solution, call it a hack, call it a workaround for that problem, is to have these so-called header guards. They're not exactly part of the C syntax, but it's something we can create with the C syntax using this other kind of preprocessor macro, the if not def or pound defined and end if. It's exactly kind of how it looks like, and that's sort of like a if statement, but it's a preprocessor macro, meaning just like our pound include statements we've had to include other files, this happens before anything else gets compiled. It's actually checking, as I'm about to compile this file, this .h file, was there a token, was there something defined called file name underscore h? You can call it whatever you want, it just has to be something unique. You can't then reuse this for some other purpose. So usually if you take the name of the file and make that a token, that should be unique in your system for that program. If it hasn't been defined yet, so if not def, if it has not been defined, so it's kind of like an inverted if statement. If it hasn't been defined yet, define it now. And then that whole if statement, although again, it's all preprocessor macros, so there's not nice little curly braces to let you see obviously where like the if statement encompasses, but effectively it encompasses the entire file the way this is written. This if statement that starts up here is then finally ended by this other kind of end of that if statement. So basically what that guard does is it says, okay, compile this file as many times as you want. But only the first time it gets compiled as you're compiling your whole project will that token file name h not have been defined. So the first time you compile it, if it's not defined, let's define it, and let's now compile all this stuff. The second, third, fourth, fifth, 800th time you go to compile that file, this token will already have been defined. And so it's going to effectively still compile the file, but it's going to skip the whole file. And so you don't wind up with things like your types or constants or functions getting defined multiple times. Another way to kind of just process this information is just to realize, okay, I'm creating a .h file. First thing I do, the very first thing I do is I add those header guards, and then I don't have to think about it for the rest of the development of that file. Because it is, very common practice. I have here open somewhere like math.h, which we are using, right? When we want to include some of those mathematic functions, this is effectively part of the C standard library. It has a very long history for it, but effectively the first two lines of that file that are not a common are exactly those header guards. Again, it's a little hard to read because it's not structured like C code because it's just these preprocessor macros, but that's what it is. There's an endif at the end corresponding to that if not def at the very beginning. So that means you can include math.h as many times as you want in your program. And again, you may say, I would never do that. Why would I include math.h twice? Well, you would do it in one file, and then that one file would have its own include, and that include file would include math.h. And if you were perfectly well structured and very carefully thinking about the organization of your project, this wouldn't be an issue. But in practice, it does become an issue. If you didn't have these header guards, this file would potentially get included multiple times, and then you would get some compiler errors along the way. But the rest of what's in that file is effectively just things that are potentially common context, like these pound defines, like we've been using for that purpose. All the various types we may want to use. We've played around with the enumerated types. We're going to start playing around with structs very soon here. It's a very natural place would be to define that in your header files. And then your external function declarations. They can go in the C file in which they are being used, but as we've seen, there's some issue with that in terms of where is the prototype defined relative to the implementation of the function. If you then put all of your prototypes inside the header file, and presumably also then the very first thing you do in your C file is include that header file, then you're guaranteed to always have the definition for those functions available before you actually ever need to call or use the implementation of those functions. And that's what math.h is doing as well. Again, there's now sort of decades of historical baggage associated with it. So I don't think it'd be that fruitful to kind of go line by line through it. There's the ability to call a C header from C++, and that's the standard way to do it, to check if it's actually being compiled with a C++ compiler. But then after it's done so, it has all the definitions for the functions corresponding to the things that are supported in math.h. And it's the floor, the ceiling, the sine, the cosine, all those functions that we've been using a little bit here and there this semester. Also has some defined structures and types associated with it. And then there's some various constants that are useful for the math library. So somebody asked me earlier a couple weeks ago, well, how did you know that m_pi would give me a nice constant for pi? Well, it's just defined in math.h, and that's just part of the spec for math.h, and it's literally defined on that line, and those are all the other constants it actually defines. If this isn't enough, you could always define your own in your own program, but when you use math library, when you use math.h and the corresponding implementation, you kind of get those constants for free in your program. That's really all I have to say with regards to functions. I just want us to go through just one more example in class of playing around with functions. So I'm going to double back a little bit to this problem solving exercise that we'll just work on together versus kind of starting from base principles and then writing code from an empty file. This function is just printing out a playing card on the command prompt. As we start to gain more techniques this semester, we will gain more capability for making things look very nice on the command prompt, but we can get pretty far with just a bunch of well-formatted printf statements, and that's what we'll do with this example B. The nice things, we can support some Unicode characters and actually just directly print those out. Not all systems support that, but we can actually take care of that. But still, as part of that problem-solving process we've been trying to follow, So here I'm telling you we need to write a function, like I said. When do you write a function? At least in part when I tell you we're writing a function. But we have a function that's going to print a card. What should we call it? I didn't say that there, but that's also part of it. What should we name our function that's going to print a card? You get to choose. Okay, it's going to be called print card. It's a wonderful name. Hey, people get really stuck on naming things, both variables and cards. And anyone who's been in my office hours, when I see your code that every variable is called temp1, temp2, temp3, I grit my teeth, but I let you do it. But still, it's your own code, it's your own decision. Print card sounds good. What kind of input should print card have? We're talking about a playing card here. We want to print out the 5 of diamonds, or the ace of spades, or the 8 of clubs. Well, right now, this is a function that prints out a playing card. You're right. So if it was print arbitrary card or random card, we may not need any inputs. We get to decide. I guess my thought process was, even if we wanted to print random playing cards, it may be useful to have a function that prints out a specific card, and then we could randomize the inputs to it. But you're right. The way I've specified this, I didn't really say what kind of inputs would then make sense in that instance, where we want a function that prints a card that we tell it to print. Sure. Yeah, probably, right? We at least need some way to specify that it's a 5 or an ace or a jack or something like that. Or an int, because it could be an index, whether it's the actual character corresponding to the card. And I think we'll see the 10 is kind of annoying, right? Because that's 2 characters, that's not 1 character. But yeah, something to specify the, what would that be? The face value of the card, and then something else to specify what? The suit of the card, whether it's diamonds, clubs, suits, or hearts. Sure. Quite possibly. Now, we'll see whether that enumeration makes we're going to play around with it, whether it makes our code better or worse, but it's definitely something that would make sense. You could define ace card, and then 2 card, and then 3 card, and make that your enumerated type. Oftentimes we'll see, it makes our code more logical. Does it make it any better? That's a judgment call, but we can play around with that and see as we design it, as you guys design it, we will determine what is most appropriate. So this starting code doesn't do anything yet. Just kind of checks that we can kind of manually define the Unicode sequences corresponding to those symbols for the playing cards here up in the comment here. This does depend on your editor. So, but I believe in the Replit editor, it's just smart enough that you can take any Unicode and it seems to be able to handle it as actually a string in your program. The implementation underneath the hood of this is actually a little complicated. It's why printf is definitely a non-trivial function. Unicode is a different way of encoding much more complicated type of characters than what our ASCII table provides. So all your emojis and things like that, that's generally all implemented as a defined set of Unicode symbols, of which there are hundreds of thousands of them, unlike the 256 of our ASCII table potential entries here. They have different lengths, which is also makes the implementation kind of complicated. I think for our purposes right now, how did I know that the spade was this particular Unicode sequence? I didn't. I Googled and said, what is a spade Unicode sequence? And there's websites, just like there's websites dedicated to showing you the ASCII table, there's websites that kind of document all the Unicode sequences that are available. So this is one way to print out a Unicode character, that spade symbol here. It's a multi-byte sequence. It's \U to hint that it's Unicode. We would print it out as %S because it's just a multi-byte character, and that's how we do it in C. But this editor also supports directly taking those Unicode constants and have that be text in your program. So this should work as well as this should work. It should print out kind of 2 copies of each of them. So you want your programs to print out thumbs up and happy faces and man shrugging and all sorts of things. Looks like it generally works. The implementation has to be supported in a few different places for that to actually work. So your actual editor has to be able to support Unicode. A lot of them do, not all of them do. The compiler has to be able to support and understand what that Unicode string would correspond to. And then the actual console you run it in would also have to support Unicode. And support for Unicode's not a binary thing. Like I said, there's hundreds of thousands of different emojis and Unicode symbols and things like that. And this console is a piece of software like anything else. And as part of the implementation of this piece of software, there is varying levels of support for what symbols are look good, which ones don't look quite as good as what in theory they could look like. You may have already kind of seen that, right? So I feel lame saying this, but like you send an emoji to someone in a text and it may look like one thing on your phone and something slightly different on someone else's phone, or you use the same symbol in Discord and it looks comparable but slightly different. That's all implementation specific detail, which is when I receive that particular byte sequence correspond to the spade, heart, diamond, or club, what will it actually look like in the underlying implementation? Well, there's some kind of low-level graphical work that's required to do that, right? To get it to look like that. Should they have the corresponding red and black colors? You know, maybe, but that's not how it's implemented in this particular shell. It's just implemented as just a black and white symbol that we have here. So that's the starting point. So we can actually print out those symbols. And the other thing provided in this code is just, okay, here's kind of a block implementation of what a card could look like. For me, when I know I'm about to write a new function, there's two ways you can go about it, I think. You could try to write a perfect function, or you can try to write a subset of the functionality just to make sure you understand what your function is supposed to be doing, knowing that you're going to have to write more code at the end of the day that way. So as you mentioned, print card is still a nice name for a function. We'll focus on the inputs in a little bit. Yes, we could put this in a header file, but we don't need to put it in a header file as of yet. There will be some inputs required. But for me, this example prints out the 5 of diamonds. I'd want to make sure I can actually do that first. And then I worry about printing out any arbitrary kind of cards here. It's technically extra work, which is kind of a hard sell sometimes. I would love to show that I understand what I'm doing with this printing and what this kind of looks like well enough to be able to print that out. And then I would worry about kind of copy pasting, refactoring, whatever you want to call it for that function, so that I'm printing an arbitrary card versus this function that's only going to print one particular card here. So I'd like us to play around with that. I know I'm writing a function. I'm just going to move this comment down here. I think it'll be useful. I like to write that prototype first because it guarantees it's defined for us. For me, I like to copy paste the prototype. Got to remember to remove that semicolon, and then there's my function, right? Then I have the exact, I know the name is correct. I know I didn't accidentally create a typo or anything like that. It's correct because I copy paste it from the prototype. Oftentimes then, because I want to make sure I don't forget, I'm actually wanting to test that function. I also copy paste the prototype and actually call the function so that when I'm about to test this, because sometimes, right, if the screen is up here and I forget what I put in main, I could be hitting run over and over, and I'm thinking, why is this function not doing anything? Well, it's because I forgot to call it, and that does happen. You know, the return statement is optional, but I think it's nice to have. So how do we go about printing this out? For this one, this function prints, based on its name, only the 5 of diamonds. So for me, because this is our simplified initial function implementation, we'll make it better in a little bit. We don't need any inputs for it.
Did you say rank is equals 5 and string receipt equals diamond?
Yeah, I think that'd be a good way to start. Well, actually, if we really want to, get rid of all the detail, that approach would work. If we just want to print out what's there, I think we can just copy paste the hard-coded strings. But then we'll refactor that as well in a second. We have those lines of code. We can just copy paste them. I could do it in one printf. Let's just do it line by line. Because again, at least this system we're on right now can handle this. There's a typo there, I see it. Can handle this Unicode just fine. The auto formatting is making this harder than it would have to be, but we're getting there. Just trying to close my functions when I don't want them closed, but we're good. We're almost there. Yes, and you can do this all with one printf line because it's all just printing out, stuff. Kind of a readability trade-off, I guess. And let's add another new line at the end there. Thank you, sir. We would have caught it if it was wrong, and then it would have been fine. And then there's our 5 of diamonds. And okay, probably you could print a nicer looking plain card, but that's good enough. That's a good starting point. I kind of agree with what you were saying about, we have to now think about data at this point. Think about our inputs. Do I need to do it in this function? Or now that I know that this function works, this is a good starting point where I do recognize that hard-coded 5 is going to have to get replaced with a %d or something like that eventually, right? This function works, let's not break it. Now we do have our function print card here, and now we really have to think about what is appropriate for our inputs. You were mentioning enumerated types. I think that's a good way to think about it. Let's think about what our actual cards are, right? So we have those strings that are defining our spade, heart, diamond, and club. One thing that you can't easily tell by looking at it, and I don't expect you to know this, is that each of those are going to be 3 bytes each. There's different Unicode formats. If you got the wrong number of bytes as we tried to define this as an array, you'd get a compiler error at least that would tell you that something's wrong. Each of those are 3 bytes each. If we want to store those so we can index into them later, we would need to use the string, the car data type for it. So if we wanted to define like club suit or something like that, we know there's 3 bytes in that pound define, or at least I'm telling you there's 3 bytes. That suit would then require 4 bytes if we want to use null terminated strings in C. Think because of the way Unicode works and how it's supported, we probably can get away with this, but for now we'll give it another byte. We'll say it'll be 0 anyway. Club suit would be that. We could then define suits for all of those. Call it like suit strings or suit vals or something like that, for which we know there's 4 suits. Guess we don't really need, you don't need to actually provide that. And we can define the suits accordingly. Yeah, maybe it would be useful to say, whether it's enumerated types or not. So the trick we've used a lot is this, right? Num suits 4. That is totally valid. There's another trick that you've started to see in some of the code that's in Zybooks, but we have not been using it. Starting in Lab 7, we'll use that a little bit, which is to use an enumerated type where you're just specifying a discrete set of potential values. If you initialize it a particular way, you kind of get that num suits pound defined for free. This is just an alternate approach, where if I want to say enum, I'm going to get the syntax for this wrong, but I think it's spade suit is going to be initialized to 0. Heart suit would then be 1. These are all kind of like individual pound defines. Suit type. Well, and it's only mad because I've already defined pound. This is another common approach we take for, basically this is no different than pound define spade suit 0, pound define diamond suit 1, pound define spade suit 0, pound define heart suit 1, diamond suit 2, club suit 3, num suits 4. You have a question about it? Sure. Mm-hmm. For an enumerated type, right? So it'd be something like ace, there's gonna be a lot of typing, unfortunately. Anyway, let's do it. Once we do it once, it's done. Once we do it once, it's done. They are always in integer values in enum. The only thing I did here was I'd set the default value, but I believe the default value is set to 0 anyway. They start at the default value and they just increment. They're effectively just doing a series of pound defines. The reason I haven't talked about them too much is you never really strictly need them. A 10 card, this is getting to be a lot of lines. Jack card, queen card, king card. You want to debate? We could do num cards, and and it should be smart enough to then say num cards. Ooh, maybe like face. I should have said. Well, no, I've already done it because num cards is kind of misleading, right? Num faces, because card is both a face, and if I trusted this thing to do like a search and replace without breaking, let's see. Rename all occurrences of card with not rename this element. Well, that's useless. Let's try that again. Hold on. I know I could type it. Rename all occurrences. That sounds like a find replace. Rename all occurrences of card with stupid replit. Okay, we'll do it manually. So here we're just defining some potentially helpful, either pound defines or we're referring to them as the enumerated define types here. So now when it comes to what is our input to our function, it probably makes sense to pass one of these or one of each of these values as an input. You could probably, it'll be fine if you give it an int instead, but we've defined this type now. And this is useful because as we talk about structured data, the syntax is going to look pretty similar. And there should just be one more. So we have a type called suit type, a type called face type. Print card then should take face type face. It seems unhappy about that. Did I spell it wrong? Declaration of enum face type. What's it unhappy about then? Unknown type face type. Yeah, the type is at the very end. We have a suit type, and they're really just a way of doing pound define. So I could have also passed it integers and it would probably be fine. So we're getting one of these, and we're getting one of these. We've also defined kind of a helper string here. Whether this should be global variable or should be defined inside the function is kind of debatable. That allows us to say, okay, if the suit is 0, I should print out spade. If the suit is 1, I should print out hard. If the suit is diamond, I should print out diamond. If the suit is club, I should print out club. That was kind of baked in for us. We may want to do something similar for face vals. And the tricky thing is we don't actually know how much we need yet, but we can start with it, right? This would be an array of strings. So I think where it's going to become a problem is the 10. Now, we don't necessarily need this array. We could have our code instead have, oh, there's our 10 problem. We could just have a bunch of if statements or switch statements that based on the face type, print out this face. Based on the suit type, print out that suit. That would actually work. The approach that we seem to be kind of making our way towards is we have defined kind of the valid range for what those inputs are going to be. And we've kind of pre-calculated, I think this might need a little bit more thought, we've kind of pre-calculated what should get printed out for the different values. We've sort of done the whole big if statement or case switch statement in advance and kind of hard-coded in our program exactly what the corresponding printf should look like for the different value of face and suit. The approach that could be thought of as like a lookup table, memoization is the other approach you may see, but in this case we're just saying, well, we know there's just a discrete set of possible inputs here or things we want to print out here. That's all there is. Why worry about an if statement? It should only be one of those set values here. So print card like I said, now when we want to test it out, maybe we should add some space in between cards just for safety purpose. Now when we want to call it, let's make sure we actually call it. Here there's inputs, so we need to actually pass it something specific. And I call it 5 face and diamond suit. It should give us the same result if our code is implemented correctly. We have them side by side, and one is using kind of the configurability of a function, one is just a hard-coded function. So print card, I'm also going to copy paste it again and start on the implementation. And to be honest, I think we're not in bad shape just kind of copy pasting this implementation. It's not correct yet, but well, hey, we're at a place we could test it. Not correct. It's still hard coded, but does the code compile? Gives us 2 different 5 of diamonds. Okay, we're getting there. We have code that does something reasonable. But now we know that when it's time to print out this 5, what should we print out instead? Well, so we could. I think, well, let's see. We started ace as 0. So a couple things we have to think about with this. If it was cards just numbered 1 through 9 or 0 through 9, this would be a much easier problem because then we could do %D. The issue is ace doesn't really correspond to %D or jack, queen, king. Those are actual characters. That's why I define this as characters and not as integers. These values give us a unique index into this array. They don't actually give us the result. So again, conceptually, it's like a big if statement. We'd be doing something like, just something like, and this is not how we'd want to do it. If face equals ace face, printf ace or something like that, right? That's conceptually what we're kind of doing here. And then for every one of the cards, for faces and then for the suits, we'd be doing that. We don't actually need to do it because of how we just happen to set up the problem today, because we have this array that defines all those characters for us. So it would actually not be %D. What should we have it print out instead? Is that what you're going to say? Yeah, %C. Now that's half the battle. Okay. Take a moment. Discuss amongst yourself very briefly. What would I need to put here? And if you've got it, that's great. But take a moment, because I can tell everyone, but I want you to think about it a little bit. I want to print a character. Editing is kind of annoying here. Okay. I want to print a character right here. So on that line 24, I have an input called face, and I have an array of face values. If my input was 5 face, what should I print out? Take a moment. We could have also called this in retrospect, instead of face, we could have called it like index, because that's what it is, right? It's an index into the array. Ace faces 0, 2 faces 1, 3 faces 2. It's kind of off by 1. That's kind of annoying, but that's how we set it up. 4 faces 3, 5 faces 4, etc. So when I get 5 face, which is what we're testing this with right now, I'm sending it 4. What should I access for that character? Take about 30 seconds. Discuss. Wake the person up next to you. Friend, help me, you say. Help each other out. Okay, any thoughts on what we should put here? Which array do we want to access at least? Do we know that? Definitely face values. So that's definitely part of the solution. We know we got to fill in that index, that subscript somewhere. And what's our index? Face values of face. And hey, we got that working. Before we forget, let's do it down here as well. Now, again, this was just kind of something that you're taking my word for now. I mentioned that these Unicode symbols are actually going to be printed with %S. That's kind of a compromise to get these to work in C. But otherwise, it's going to be exactly the same thing. Yeah.
Where's the face coming from within the array?
It's this array right here. We've initialized it, where A is the 0th element, or the very first element, or index 0. 2 is the character at the next element. Oh, and you know, now that I think about it, yep, which is the input to this function, which is going to be either 0, 1, 2, 3, 4, 5, 6, 7, etc. So when I pass it, as we called it down here, 5 face, I'm actually just sending it a value of 4. And I could have just done 4. That would, you know, it's not as readable, but that would also compile and work. I'm sending it 4. We're using these enumerated types to kind of make our code a little bit more readable. I'm sending it 4. I'm going to then print out 0, 1, 2, 3, 4, or the 5th offset into that array, 4th offset, 5th index into that array. So it's going to print out character 5. Same thing for the suits then. It's just that these are not single characters, they're actually arrays. It'd be suit values of suit. Suit values of suit. Now we got 5 of diamonds working 2 ways. That kind of tests it, but now let's do, I don't know, Jack face of heart suit. And we wanted then to also show we could print a random card. We're not initializing it. How do we print a random card? So let's add a little comment. Print a random card. What would we do? What function would help us to print something random? To do something random? Yeah, we could do srand and initialize and all that. This won't be very random. But what's the other than function that we need? That's correct, but what other function then do we need? Just rand, right? Would this work? Yep. How do we do it? I want to generate a random number between 0 and 9 inclusive. What do I do with the output of rand? %10, mod 10. Yes. I want to then instead generate a random value between 0 and num faces minus 1, right? Because I want a value between 0 and 12. So what would I do? %13, I mean, that's correct. I think for readability, probably we have that nice num faces, so let's use it. Seems unhappy about that. I think I have to include standardlib.h for it not to be unhappy. I think it would find it anyway, but there it is. Find me rand. I don't believe you. That's a weird error. Did I spell something wrong? Am I getting too old to expected? I think it's wrong. I think replit is wrong and we are fine. Likewise, we'll find out. Yeah, see, now it's happy. Yeah, so we've talked about that a little bit, right? Those little squiggly lines, that's actually kind of effectively a compiler always running in the background. A code linter, a code highlighter. It's basically checking the rules of C constantly, or as frequently as it's able to determine, are you making kind of well-known C programming mistakes? But I think because of that nature, it's not perfect. Sometimes you have to refresh the page and it's happy. Other times it's just not correct and you're better off just compiling it yourself and testing it. All right, so this should print hello world, should print 5 of diamonds, should print jack of hearts, and print somewhat arbitrary card, and there's our ace of diamonds. Because we don't seed the random number generator, it should give us the ace of diamonds every time. Because random is not really random as we've talked about, right? It's based on a deterministic algorithm to go from a starting point to a somewhat arbitrary looking sequence of points, but it'll give us the same value every time if we don't seed that random number generator ourselves. If we didn't want to deal with the t, because that one's kind of bothering me, so there's Jack. Let's comment out that one now. We can comment out that one now. And because it does work, we'll comment out that one. If we want to print out the 10 of clubs, good hand for blackjack. The T is bothering me. Help me refactor this code. I don't want T, I want 10. Why won't that work, first off? Just looks okay, like logically it seems like, yeah, just put 10 instead of T, but why won't that work? It's 2 characters, right? And, I defined this array kind of manually like that. We could have done car face values of num faces. Do we technically need num faces plus 1? That's a good question. For now, we'll ignore it. We could have just defined it like this. T, J, Q, K, right? Because that's also how you initialize an array of characters. That's what we're referring to as our C string here. Technically, there's 13. Technically, I want to make sure it's got room for that null byte at the end. I don't think it matters. Sure.
Num faces times 2 plus 1 and add a space after. I think that when you define num faces times 2 plus 1 and add a space after every character, except
That's absolutely what I was thinking about. Because, okay, let's just follow the train of thought that I think you have going on. Even so, syntactically, this approach down here doesn't work. It's not a character. It's not going to compile. It's 2 characters. You can't initialize it that way. God, it's possible. I would never do this. Can I do this? I guess so. That seems like a bad idea. I'm not so sure I can. So anyway, let's assume that is itself a compile error. Conceptually, this will compile because now it's just a longer string. It's unhappy about the length. We can make it one longer to make sure it has the element. Again, we spent a little bit of time a week and a half ago talking about how many, and there was a macro quiz question on it as well, how many bytes you need to properly store these C strings. That is when you're using something as a string, when you're going to printf the whole array, or when you're going to use string copy or string length. In this case, it doesn't matter. We're grabbing just individual elements here. So in theory, this kind of thing would work. The logic for which one of these to grab was very simple, and now we could still probably figure out, but it's going to be if statements and messiness. Another workaround then would be, well, give everybody 2 spots. I kind of agree with that. Everybody gets 2 spots, and that's why you said 2 times num faces. We don't need the plus 1 anymore. 2 times num faces, and then we're going to print out not a single character down here, but, and I'm going to refactor it already, %C, something like that. Yep. Good point. Missed it. Good point. Boy, it looks wrong, doesn't it? Right now, the way we've written it. I think also, so part of the trade-off is we're building arrays, and for the most part, I've been telling you, use this size array or construct your array this way. And one approach isn't wrong, one approach isn't right, is whether we want to have a single long array or whether like adding more dimensionality to the array would make our code a little bit easier for us to understand. And I, this is my own personal bias. I think this version might be easier for us to read. We'd have to still refactor it a little bit, but now it's going to be kind of an array of size, it'd be num faces of size 2, not 2 of num faces, where we're just storing those individual strings as arrays of strings as we go. So it would be the A string and then the 2 string. Debatable. Not right or wrong. To me, this is going to be a little bit cleaner to understand what's happening once we implement it inside that function. As I call it easy here, watch the typos mount. Give ourselves a little bit more space. Then 10 just kind of sits by itself, as you mentioned. Now it doesn't look as wrong anymore, in the sense of now everything's fitting where I want it. Seems unhappy. Face values, num faces 2. This is an array of strings. I don't need those brackets. So each string is itself its own array, and I have num faces of these arrays. So it's a two-dimensional array. Thought that looked bad. So now when we print, it's not face values of face. Well, first off, we know it's two things we're printing. So it's face values of face and something else. 0 and 1, I think 0 and 1 should work. So face is still an index into the first dimension of this array. You can think of that as the row of that array if you want to. It still grabs the equivalent entire string. That's the next dimension. Then we still want to figure out which of those we want. We want offset 0 and 1. I'm a little worried about how this is going to look down here, I got to be honest. But we can certainly try it. Try not to think too far through it. You're going to have really wide chunks. Because of how we're printing it, now I understand what you're saying. That's one extra space that we don't actually need anymore. Easy enough to fix, that one. I thought this might happen. This approach is still a good approach. I still entirely stand by this approach. There's still a very slight bug, in my opinion. Printer's error of this kind.
You could just switch where the spaces are and num faces.
Well, I like the way you're thinking. What's going to happen when we do that? We're going to replace one bug with.
So it'd be space A, space 2. Oh.
Yeah. So let's this is getting unnecessary, but if we recognize that there's an alignment issue, that was the bug, and he's got the advantage of being in the front row, being able to see it a little bit better. That's kind of technically off. So we want J space, and we also want space J, or A space, and we want space A. Let's just add it. But we've been so if-free so far. There's been no logic in this code whatsoever. This is showing the power of our arrays here. It's complaining about each of these little substrings because we just didn't define the length yet. So for 10, it'd be 2 copies of 10. And then finally king. Probably this looks a little bit better if it's not falling off the page here. So there's no requirements that all fit on one page. It's not of size 2 anymore. Now it's of size 4. It should be happy once it sees that. Debatable whether it looks better. And then for this one, we would just want to then print. We want to print that space first. That'd be face offset of 2, face offset of 3. We now have nicely aligned 10 of clubs, jack of hearts, and things like that. Now, the whole point, and this really was the whole point beyond just playing around with libraries in lab number 6, is taking your functions and building upon them, right? We don't do this here quite yet. We did work on, start with something that kind of is hard-coded that you can wrap your mind around, that you get something back out, and then abstract away the inputs, potentially the outputs as well. I think it'd be very likely we would want to have a function that then prints, not one card, but prints a hand. Well, we could just call it print cards. That would be fine. If we had a function called print cards that's going to print multiple cards, what kind of inputs would it need? We're almost done here today. Print card takes a single face and a single suit. What would print cards require? That'd be, 5, depending on the size of your hand. That's how we would probably do the implementation. The downside is it would print the hand kind of vertically. Printing it horizontally we could also do, but it would take more time than we have today. What kind of inputs would the function then need for the different cards? We need an array, I think would be the right way to think about it. Yeah, you got it. Call it faces. You don't need to specify the length of the array when you provide the array as an input. Same with the suit. But usually, unless you're working with C strings that we can calculate the length, we usually have to then, when we have arrays as our input to our function, provide an additional input that specifies the number of things we're going to be printing here. But I think you're right. The implementation of that becomes a for loop. It's going to print it vertically, but it's still better than nothing. So for int I equals 0, I is less than num cards, I plus plus, just call print card of faces of I. That doesn't look right. Print cards, faces of I, suits of I. Seems unhappy about that. Print card, individual card of faces of I, suits of I. Maybe we shouldn't call our function something so very, very similar, but that is how we would implement that. And then when it would come time to actually call this function, print multiple cards, we would then need to define that array. So I don't know, face type my faces equals, these are the faces, right? So I don't know, ace face. And the suits I want to print. You can also randomize it as well, right? Heart suit, spade suit. Seems unhappy about something here. I think I know why in just a second. I didn't define the array properly. These are our enumerated types. It's still an array, so let's actually make it an array when we declare it. We could specify that size of the array if we want to. We also don't need to, because we're initializing it in an initialized fashion here. So when we actually want to call it, we would just call it with the name of the array. We don't need to use the brackets syntax then. I'm passing in my faces. I'm passing in my suits. And then for number of cards, I should print out 4. Fingers crossed. There's our very nice hand, at least for poker. Let's leave things here for today. Come to office hours today. I'll be happy to see you.